Okay, so today we're going to look at the cosine rule. Um, Cosine rule, it looks a little bit more difficult than the sine rule, but when you think about where we come and we look at this formula, we started with right angle triangles, and this part of the formula here looks suspiciously similar to something else, Pythagoras' theorem, doesn't it? And that's exactly where the cosine rule comes from, Pythagoras' theorem. And it's a derivation because we are not dealing with right angle triangles. Pythagoras only works with right angle triangles. This part here just changes the formula because we are not working with right angle triangles. We still label things opposite. So this is side A, angle A, side B, angle B, side C, angle C. So let's see how this formula works. So here we've got it where I'll look in to try to find side A here. So what we've got is that A squared equals 14 squared plus 12 squared minus 2 times 14 times 12 times cos 35. Now, it doesn't matter which side we call B and C. If we'd have done it the other way, we'd get exactly the same thing. Okay, so all we're going to do now is we're going to substitute into the formula, and that's what we get there. We get A squared equals 12 squared plus 14 squared. See, I've swapped it around. It won't matter any, like if we'd have done 14 squared plus 12 squared, that's exactly the same. So I've swapped it around here. It doesn't change anything. Minus 2 times 12 times 14 cos 35. And the easiest way is to put that all into your calculator in one lot. 12 squared plus 14 squared minus 2 times 12 times 14 times cos 35. And what we get is 64.76. Now, this is the first mistake that lots of students will make. This side isn't 64.76. If this is a triangle and this is 14 and this is 12, this is not going to be 64, especially when you consider that this is the smallest angle, so this should be the smallest side. So I wonder what's happened or why we've got this 64.76, because I know that's not the right answer, but how do we get to the right answer? Well, this is what A squared is. So if A squared equals that, we have to take the square root of this 64, and we get that A equals 8.05. And that is a lot more believable or a lot more realistic. This is 12 and 14. This is the smallest angle, so this is going to be the smallest side. And that's all the cosine rule is. Again, you've just got to be careful. If you get an unrealistic answer here, most of the time it's because you forgot to take the square root. Okay, so let's look at another example. Very similar example here. This is 60 degrees, x. We haven't labeled the sides, so it's going to be x squared equals 42 squared plus 39 squared minus 2 times 42 times 39 times cos 60. So all I've done, I've just moved the formula down here, see, and it substituted up here. And again, I've substituted quite poorly here. 39 squared, so this is B, but over here I've swapped it around. It doesn't matter. This is our B, this is our C, B, C, as long as we put it all in. So 39 squared plus 42 squared minus this, we put it all into our calculator. Again, we get x squared equals 1,647. Again, this is not going, if you think of a triangle, this is not going to be over 1,000 if this is 39 and 42. We would actually expect it to be somewhere in between 39 and 42 because this angle is 60. So if we look at that, we take the square root. How did we get from here to here? We took the square root. The formula says x squared. We don't want to know what x squared is. We want to know what x is. So x is the square root of this, which is 40.58. We'll just have a quick look at the last example here, and I won't go through it. I'll just leave you with a few questions. So in terms of this triangle, you've got a 60 degrees. You've got it's two 18s on one side of 18 and one side of 18. What I want you to do is see if you can find the value of x. And when you do find the value of x, and it comes out to be something a little bit weird, perhaps, maybe you can see what the answer is already. Just try to understand where we got that answer of x from, especially when you get it. And could have you expected that answer right from the start? Thanks. Hopefully that explains the cosine rule a little bit.